Yes. In the last class, we have seen in the open loop control systems, what are the drawbacks of the open loop control systems? Right, due to the internal disturbances, that is internal parameter variation, and due to the external disturbances, here the input that is the output is deviated from the desired value. So that is the drawback of the open loop control systems. That means in the open loop control system, if the input is calibrated as per the output, you will get the desired outputs. Right? Then how to overcome this problem? By using the closed loop system. So in a closed loop system, whenever there is a change, whenever change the output, the system is automatically recorrect itself. So that is the signal is moving from input to output as well as output to input. So with the feedback concept, you see clearly in the black diagram. So in the black diagram, we are using the three elements, that is control element, plant, and feedback element. These three are the elements, right? These three are the elements, and the signals reference, that is actuating signal, control signal, and feedback signal. These are the signals. So if you use the unity feedback system, that is that whenever the feedback element is unity, that is equal to 1, then the controlled output is equal to feedback element. Using here the plus and minus are indicates that the positive feedback system or negative feedback system. So we are using for example, if it is considered as a negative feedback system, then the actuating signal, so very important concept, this is an actual input. The actuating signal is equal to the difference between the reference input and feedback element. If you take the feedback, that is unity feedback system, then the actuating signal is error signal. So only if you take the unity feedback system, then the actuating signal is error signal. If non-unity, that is if the feedback element is not equal to 1, then the actuating signal is not the error signal. So that is the concept here. So actuating signal is also the error signal for the unity feedback system. Now with this concept, the difference between is also error signal. The difference between the open loop system and closed loop system. So these are the basic differences. So as we discussed with this example, we will the differentiate the open loop control system and closed loop control system. So open loop control system is very simple because the input is moving from input. The signal is moving from input to output, and we are using the less components only. So that's why it is less cost. But whereas in a closed loop system, we are using more components because the feedback concept is required. So that's why it is more costly and complicated. Signal, the second point is here, the signal flow from input to output only. But whereas in the closed loop control system, the signal is moving from input to output as well as output to input also. In the third point, control action does not depend on output signal. The third one, whereas in the closed loop control system, is the control action depends on output signal. So that is very important. Here the control action means because of the control action only the actuating signal is changes. So you see this diagram, control action. So actuating signal is continuously changes. So control action is completely depends upon, whereas in the open loop control system, it does not depend upon the open outputs. So this one is not depends upon this one. But whereas in a closed loop system, continuously the feedback is we are getting the outputs. So continuously feedback from the outputs and changes with the, I'll compare with the reference value, the actuating signal. So that's why here the control action depends upon outputs. So that is the third one. So that's why only this is a mechanism it is there in the controls in the closed loop system. That's why that outputs whenever the output is changes deviates, then the system is automatically recorrect itself. So the fourth point is due to the internal and external disturbances. the output deviate from the desired value in open loop control system. But in the fourth point in the closed loop control system is, if the output is deviate from the desired value, immediately it is automatically recorrect itself. And the fifth point is, no feedback element is used in open loop control system, but whereas in closed loop control system, feedback element is used. So these are the very basic differences, and we'll list out some more, that is some other 4 or 5 the differences of between this open loop control system and closed loop control systems in further studies, next classes. So these are the basic differences, and so in the next classes you have to you'll study the main syllabus as per the curriculum. Your syllabus is before you are going to the syllabus is, so I will ask a question. If I will write one example of open loop control system and closed loop control system. Right. For take automatic washing machine. Is that automatic washing machine is an example of open loop control system or a closed loop control system? Generally automatic. So closed loop control, what is the meaning of closed loop control system? The output is, whenever the output is deviates from the actual desired value, it is automatically recorrected. So whenever the word will come, you don't think that it is only the closed loop control systems. We will check it once again. What is the function of the automatic control systems? It cleanliness of the clothes. So control action depends upon the output signal. Am I right? Whenever the output, what is the output here? So in a automatic control system, in a automatic washing machine, so in the washing machine, what is the desired output? So we'll get the clean the clothes. So clean is the complete cleanliness of the clothes. For example, if a very dirty cloth is put inside the cloth, so we are not getting, we are getting the complete cleanliness of this cloth? No. So here in automatic control system, the control action is completely depends upon the time setting only, time setting. So whenever we are correcting the time setting, it is completely, whether it is a very neat cloth or a dirty cloth we'll put, it is the washing is completely the cleanness of the cloth is depends upon the time setting only, not depends upon the output signal. So whenever the control action depends upon the output signal, then only it is called closed loop control systems. But whereas automatic control system, it was not happen. That output signal, it completely depends upon the control action is completely depends upon the time setting only. So that's why the the automatic washing machine is an example of open loop control systems. It is not the closed loop control system. Right. So generally, as per the total syllabus, it is divided into the 3 parts. So the first part is, first chapter is modeling. What is the meaning of modeling? How to represent the system, right? So representation of the control system. So generally, how to represent any system? So by using a mathematical concept. So that is mathematical modeling of the control systems. In second way is black diagram representation of the control system. Here in the third part is signal flow, because the signal is moving from input to output as well as output to input in different types. So that's why signal flow graphs representation. And fourth one is representation of the state equations and output equations. Right, state equations and output equations. The second chapter is analysis of the control systems by the time domain analysis and frequency domain analysis. So in the first chapter, so we'll see the modeling means representation of the control systems, right? In the signal flow graph and representation, and the fourth part it is there, the representation of the control system by the dynamic equations. That is how to write the state equations and output equations. The meaning of the black diagram of the representation of the control system is, it is a pictorial representation of the control system. We'll go to the second topic here, analysis of control systems. In this topic, we will analyze the existing control systems. So already existing control systems that we have to analyze. So in both time domain and as well as the frequency domain, that is in the form of time response analysis and the frequency response analysis. Whereas even the third topic is there, it is the designing of the control systems. So in this topic, we will try to design the new control system. So for this, to design the new control systems, we will study about the compensator and controller of the system. So everything we'll discuss topic wise in future classes. Right. Thank you.